Hi everyone, let's take a look at the following example. Find the antiderivative of 1 divided by x squared minus 1 with respect to x. There's a technique called partial fractions, and the idea is you want to express 1 divided by x squared minus 1 as a sum of two fractions. So if you look at this carefully, x squared minus 1 could be thought of as x minus 1 times x plus 1, where there are two numerators, a and b. So the goal is you want to solve for a and b. And once you solve for a and b, you can break this apart and work it out accordingly. So if we really look at this, 1 divided by x squared minus 1 equals to a times x plus 1 plus b times x minus 1 divided by the same denominator. So what you can really do is focus on the numerator, so you can equate the left-hand side with 1. Now, if 1 is too difficult to understand, you can always go back and think of it as 0 times x plus 1. So again, if you look at the right-hand side, you can factor x to the front, which means it's going to be a plus b times x plus, in brackets, a minus b, just like that. Now, I know you know how to solve this because this is basically two equations with two unknowns. And when you work out a and b, a, which I'll use a different color here, equals to, let's use a different color, a equals to positive half, and b equals to, in this case, negative half. So again, you can solve the two equation, two unknowns on your own to get back to this, because now you can express this as the antiderivative of 1 divided by 2, x minus 1, minus 1 divided by 2, x plus 1, and you're integrating it with respect to x. Now, the difficult part is over because once you can express it with partial fractions, this means this equals to half, which you can bring to the front. The antiderivative of 1 divided by x minus 1 is going to be ln of x minus 1. Same idea, bring the negative half to the front, times ln of x plus 1. And of course, don't forget you have to add a constant. So if you want to double check all your work, again, at any given time, spend that extra minute, go back, find the derivative. So if you go back and you find the derivative of the answer, you can get exactly the question back. I hope this makes sense.